All right, problem 5 from the free response section of the 2023 AP Calculus AB exam. So again, no official solutions have been out, and they won't be out probably for a few months, but I'm pretty sure I got this down. So let me know if you have any questions in the comments, or notice something that may be strange about my solution. But here we go. All right, so problem 5, we got the functions f and g. We're told they're twice differentiable, and we have this table that shows values of these functions and their first derivatives for these values of x. Part A, let h be the function defined by f of g of x. I'm going to find h prime of 7. Okay, so let me try to do this up here. So h prime of 7, that will be equal, remember this is going to be chain rule, so this will be equal to f prime of g of 7 times the derivative of g of 7. So the derivative at the inside. So we find g of 7 is 0, shown here. So we have f prime of 0 times g prime of 7, which is 8. F prime of 0, we look at this, we have 3/2 times 8. And so then our answer is 12. Or part B, let k be the differential function such that k prime of x is equal to f of x squared times g of x. Is the graph of k concave up or concave down at the point where x is 4? Give a reason for your answer. Okay, so let's calculate this. Let me do it over here. So what we want to do is find the second derivative of k, and then if it's positive, it'll be concave up, or if it's negative, it'll be concave down at this point. So we want to find the derivative of this entire function. So k double prime of 4. So it asks specifically at 4. So what we do is we're going to have chain rule mixed with product rule. So we're first going to take the derivative of this, which will be 2 times f of 4 to the 1 power times the derivative of the inside, so times f prime of 4. We keep the g of x, or in this case g of 4, the same. And using product rule, we then add it to, this time keeping the f of x squared the same. In this case, it's 4. F of 4 squared times g prime of 4. And we just work this out. So we have 2 times f of 4. F of 4 is 4, coincidentally, times f prime of 4, which is 3, times g of 4, which will be negative 3, plus f of 4 squared, so plus 4 squared, times g prime of 4 squared, so times 2 squared. Hold on, did I mess that up? Plus f of 4 squared, let me double check that I didn't screw up, times g prime of 4. So it's just times 2, yeah. Let me just multiply this out. 8, 24, negative 72, plus 16 times 2, so plus 32. We get negative 42. And so it's going to be concave down because the second derivative is negative. Concave down since k double prime of 4 is less than 0. All right, in part C, let m be the function defined by m of x is equal to 5x cubed plus integral from 0 to x of f prime of x, or f prime of t dt, find m of 2. Okay, so this will simply be, let me try to squeeze this in here. M of 2 will be equal to 5 times 2 cubed plus the integral from 0 to 2 of f prime of t dt. 5 times 2 cubed, so 5 times 8, so 40. Plus, now we want to find the antiderivative of f prime, which will be f of x, which is be the function of f. And for that, we're going to, again, use the fundamentals neighborhood of calculus. So this will be f of 2 minus f of 0. We get 40 plus f of 2, which is 7, minus f of 0, which is 10. So 40 plus negative 3, and that'll give us 37 for C. All right, and D is the function m defined in part C, increasing, decreasing, or neither at x equals 2. Justify your answer. So in this case, we want to find the derivative of m of 2. So we want to find m prime of 2. So we want to differentiate this entire expression. So let's work it out down here. So m prime of 2 is equal to the derivative of this, but we're going to plug in 2 for x, so we just save a step. So 3 times 5, 15, x squared, or in this case, 2 squared, plus, when we take the derivative of an integral, it cancels out the integration property. So all we then have is f prime of t, and since we're evaluating at 2, we'll have f prime of 2 there. And then we just have 15 times 4, or 60, plus f prime of 2, which we can see is negative 8. And then we get 52. And since 52 then is positive, it'll be increasing because then m prime of 2 is positive. So increasing since m prime of 2 is equal to 52, which is greater than 0. All right, and that's all there is to it. So I hope that helps. And again, let me know if you have any questions by leaving a comment. And on to the next one.